Hello guys, if you have seen in Mr. Tesla 1337's channel, you have seen that I uploaded a similar video, and yes, there's a carbon rods, and I used 100 volts in that video, but today I'm going to use 325 volts for this one. That's rectified 230 volts, that's a peak voltage. Let's take a look at the setup. Yes, and that 325 volts is the RMS voltage. This is a cable from the variac, goes up to the 5-pin connector, goes into rectifier, which is on that little copper plate. It's 10 millimeters thick, and it goes. Before that, it goes to MOT, which works as a ballast on the AC side. It goes to the rectifier. Out comes DC, goes into one of the rods. Another part goes into another MOT, which works as a DC choke. And that goes to the other carbon rod. Yes, and these carbon rods get very hot, very bright. And then we get a little arc in there. And yes, maybe one day I will be able to use one of these water-cooled carbon rod. So the water inlet's here, cools down all the way up here, and the copper conducts heat very well. And that's the outlet. And here I connect the wires. And that's a carbon rod. As you see, it's soldered directly on there. There's a copper coating on that. And it's very easy to remove it. Just heat it up, take it out, put a new carbon rod in, solder it to place. Very nice. The tube is actually very similar to the diameter of this carbon rod, which is very good. As all parts are soldered on. It's actually meant to be water cooled, so solder wouldn't actually melt when I actually drive that. So actually it's supposed to conduct heat away from it. Yes, and that rectifier is just one of these rectifiers. It's a 600 volt one, but most of these are 200 volts. And yes, I'm driving that directly from the mains. As you can see there, the inverter is turned on, so if that shuts the fuse out, I will still have a backup power. And in here we can see that the inverter is turned on. That's the inverter's light. And that's the grid available. So back to this again. Let's turn it on and see how it looks like. So here it is, lights turned off, I got my welding glasses on, and I will just touch them together. It's variac of full voltage, goes for isolation transformer of course. Yes, that was the arc. I will put that little welding glass right there so you can see it. So that's how the arc looks like. Now I'm going to keep it like that till it heats up. And that looks absolutely good. It's a very tiny arc in the middle, as you can see from the welding glass. There are those arcs. You have to bring that close together. Like so. You can see it's very bright. That's all that from that. It's very hot. You can feel the heat. see that full voltage, it's not, as you can see there is a voltage drop. And now it had stabilized. And now we're going to break the arc. That was nice. MOT. And there you can see the voltage. That's bright. I want that to stabilize itself. 6 amps from the mains. That's bright. That's all from the MOT. Did no lights turned on. Now MOT, carbon rods. Now smokes, so I'm gonna disconnect it. And it gets dark. Let's see on the aftermath. Yes, the MOT is not so warm. Same with the rectifier. That's a good thing about having a higher voltage. You can have a lower current, so the things don't get so hot. Same with that, not so much heat in that. And that's just the battery voltage for inverter. Now we don't need the inverter. So everything looks nice and cool without those carbon rods. And just turn down the variac. And done. Thanks for watching.